Let me give you a little history about energy codes. Some of y'all, I'm guessing, have been in. Let's do a little survey. I got an idea. You want to do this one?
Okay.
The survey. Okay, we're going to try this. Everybody stand up. Okay? This is our first thing we're going to do. Everybody stand up. You've been sitting too long. You need to stand up. All right. Okay, so you have to sit down if you've been in this world of design or construction or whatever, 5 years or less. Anybody here 5 years or less? Sit down. No one sat down. That's impressive.
I sat down.
Roxanne had to sit down. It also says something about how old some of us are. Is that not true? Okay. All right, how about 10 years? If you've been in this industry less than 10 years, you got to sit down. Okay. The ladies are sitting down. I'm the youngest, right? That's it. How about 15 years? Anybody been involved in this less than 15 years? You got to sit down. Wow, this is going to be last man. We're going to 20 years. Who's been involved for 20 years or less than 20 years? That's impressive. Okay, I got to do some math on myself on this one. Wait, I got to go back. I'm going to say 25 years. I think I'm right. I think I'm going to sit down at this point. I'm awful close to 25. All right, we're getting awful close here. We'll go by 27 years. How's that? Anybody 27 years going to sit down? We lost one. 29 years. All right, yeah. All right. 32 years. Anybody 32 years? We'll go. My goodness. 34 years. I can't believe this.
All right,
too
come
young.
on in. Start telling us.
Yeah, I know, really. All right, no, we got to go. 36 years. Anybody? We lost somebody, finally. 36 years. Okay, all right. Doc, give us your number. Tell us, what's your number? 41? 39? 36. Impressive. What do you think? Let's clap for this. That's impressive.
Yeah.
So
So
not
you
to
guys
make you
know the
feel
first
bad,
one.
but some of you have been in the industry longer than before Landon and Roxanne were born. I just thought I should. And that's, by the way, that's Landon, one of our coworkers. So why is this significant? Well, back when some of you started construction, we didn't have any kind of a code in terms of energy, maybe not a code at all. And codes have evolved. The kind of earliest codes in terms of energy nationally are maybe about 20 years ago. And those are the early. Does anybody remember these? The model energy codes? There were little yellow books. I barely remember them. I was cleaning my office out and I found one. They were kind of an early attempt at a code. I'm going to say they were very complicated. Reading through them, you're like, too many engineers in the room. I'll say that. But probably Georgia had one kind of in the early 90s, and they definitely had the 95 model energy code. And does anybody remember when we more or less had to start using double pane windows? If you've been around for long enough in this industry, remember when we pretty much you had to use double pane windows. A lot of people had already gotten there. Then in the year 2000, we had a more substantial change. This was an orange code book, and probably some of y'all do remember this. This is when there was one sentence in this code that for the first time ever started dealing with air conditioning, and it dealt with windows. And it said, if you're in a part of the country that has less than 3,500 heating degree days, and that was, by the way, most of Georgia, maybe except for the very tippy top, most of Georgia, you have to have low-E windows. It didn't say low-E windows. It invented a new term called solar heat gain coefficient, very similar to the old shading coefficients that some of you architects may remember. But solar heat gain coefficient was a term that they came out with, and it said that has to be below 0.40. Well, the cheapest, easiest way to do that was with a low-emitting coating on a window. So low-E windows, in essence, became the standard in our state. Georgia adopted the 2000 code in January 1 of 2003. We had a 1-year delay on that low-E window requirement, but in January 1, 2004, we've had low-E windows ever since. So for the past, if I'm doing this right, 7 years, we've been a low-E window state. We were one of the first states in the southeast to do it. It's Georgia and Texas. And a lot of people were afraid the sky was going to fall by doing this, but it completely was the smoothest transition that went with complete no hiccups, once it actually went through. There was a lot of good education, a lot of good feedback on that, but we went to that. Now most of the other southern states have caught up to that. The next version of the code was the 06 code. It had a dramatic simplification of the code. It got rid of really crazy, it had a lot of climate zones. We're now down to only 3 climate zones in Georgia. Alabama has 2, South Carolina has 1, believe it or not, 1 climate zone. And they also eliminated this calculation, which was a real pain, which was to calculate all the walls and then the percentage of all the walls that were glass, and then that stuck you into a different table depending on what that number was. It was a big pain in the rear end. And finally they said, what they did is they said, look, you can use all the windows you want. Okay? You can use all the glass you want. We're going to assume sort of a base case code house would have about, I think, 18% windows. But most houses probably, chances are, come in less than that. If they come in more than that, so be it. The only rule is you got to use good windows. Well, we were already there. We were already using good windows. So it really didn't impact us in any significant way. And so the 06 code was a simpler version of the code, and that is sort of the foundation for the current code, the 09 code. The 09 code, it looks very much like the old code. There are some tweaks to the prescriptive things that we've been doing, but not a whole lot real dramatically. Probably, and I would say by far the most significant change, is that this code is now, in essence, requiring us to test things to prove that they're tight. And there's 2 things that we're testing. We're testing the building envelope for air leakage, and we're testing the ductwork for duct leakage. Because if you go to an existing home and you measure those 2 things, they're really good indicators of how good or bad the home is. So the tightness of the house and the tightness of the ducts are absolutely crucial to the real performance of any given home. So this test is now part of the code. And that's probably the biggest change. Any other big change? Lighting, you want to mention that one?
Lighting makes its first appearance in an energy code. Let's not get scared, though. It's not that difficult. It is actually that 50% of your lighting fixtures have to have either have a motion sensor, so an occupancy sensor, or it needs to have a high efficient light bulb installed. So that's your compact fluorescents, your CFLs, or a fluorescent tube lighting that is actually very efficient. You can also do some other ones. We'll kind of get into depth later in the day, but just kind of tease you about it that it's, lighting makes its first appearance here.
Yep. Don't fret about lighting. It's really not that bad. It's something that might sound scary, but it really isn't. It's not going to be bad. We'll make sure we cover that. Does anybody have any questions so far? So that's kind of a quick overview. The code is probably 10 to 15% more strict than it used to be. And there's some good value to why this is in here. So, maybe one of these will trigger you. Maybe it's just because it's the law and you got to do it. But I think there's a lot of good economic reasons why we need to do this, because buildings in our country consume the most amount of energy of anything else. Homes and commercial buildings consume about 40% of all the energy in our country. About some percentage is transportation, some percentage is industry, but buildings are the biggest of all those thirds. Also, keep in mind, Georgia imports every bit of energy that we have. I say that, but pretty much most of our energy comes imported in the form of oil, in the form of natural gas, or in the form of electricity. What's our fuel that we use for electricity here? Coal. And that doesn't come from Paulding County, does it? Coal comes from out of state. So every time, the coal cars come in, the money is leaving our state. So there's incentive economically for us to keep the money in our state. We do the code right, we're going to make homes healthier. We're going to make homes a lot less drafty. They're going to be more comfortable. We're going to actually reduce your liability if you're a builder, because you're not breaking the law. That's a good thing. And I think that in the end of the day, we're going to build better buildings. And that's, I think, what we're all about, trying to build better buildings. So there's a lot of, I think, value added that the code brings to us. The energy code has historically had a tough time stacked against the other codes, because the other codes are life safety codes, right? I care about the safety codes, but this code saves money. I care about that. I care about your safety, yes, I do. I care about, the money as well. And environmentally, it's a good thing if we save energy. So there's some good stuff. Anybody have any comments on that? If only there was a large power plant nearby that we could all think about. Just hypothetically, if there was a large power plant. Oh yeah, that's right. There is one. Oh yeah, that's right.
Right there.
If only there was a large power plant nearby that we could just think about that. And you should do this. Tell us about how efficient is that power plant?
All right, so let's just take an example of 10 units of, let's call it energy, come into the power plant, a coal-burning power plant. How many of it actually gets to your home? Do you know how many? What percentage?
So in other words, you're bringing this coal in from West Virginia or somewhere.
Of like energy, right? How much does that actually get to your house? Come on, I know you guys can see this.
This is interesting.
3. Right? Thank you for speaking up. I know you guys can see this. You guys aren't awake yet. Come on, guys. So let's think about that. You put 10 in this black box, and you only got 3 out. So that means if we save 1 unit of energy at your home, you're saving 3 units at the start. You don't have to put that 3 in, right? That's kind of significant to me, right? Yeah. It's somewhere between 3 and 4 units for every 1 unit you save at the home. And that's why this is really important to actually save energy, where you use it, so that you don't have to put more in at the beginning. Yep. And that's really important to me. I don't know. I find that interesting.
No, yeah, it really is. It really does work there. The power plant, literally about 30% of the energy of the coal actually makes its way as electricity into a house. And so it's always fascinating to me that the worst way, I don't know what's happening. I think the snow is melting on the roof or something. Maybe not. So anyway, the worst way you can heat your house in the winter is to use electric resistance toaster oven, right? Think about it, right? Because you took this electricity that you just spent a whole lot of energy to make and get it to your house, and you converted 100% of the electricity into heat. But that's not very efficient. What's a more efficient way to use electricity to heat a house? Anybody have one of these in their house? I'm sorry, I asked the question poorly. What is a device that has a motor in it that looks a lot like an air conditioner, but it can run backwards?
But it's electric, so it's
a heat pump. Anybody have a heat pump in their house? Okay, so a heat pump, just so you know, is more than twice as efficient as electric resistance. Okay, so a heat pump can provide, it doesn't actually turn the electricity into heat. What does it do? It transfers heat from one place and moves it to another. And that's much more efficient than turning electricity into resistance heat. So we can do some really good things, and I think just recognizing how we use energy is sort of a smart thing, and appreciating it. Always it comes back to that. It took 10 to make 3. That's a big impact. Okay. All right. Enough math. I'm done with math. Let's talk about the code. So the way today's going to go is we're going to talk about the scope and the intro and the overview of the code. We're going to do a little bit of building science, and then we're going to come back and talk about kind of the meat and potatoes of the code, the prescriptive pathways. So the first thing is the code really focuses mainly on the building thermal envelope. Okay, that's the things that get insulated, that we're going to mainly focus on. Air sealing is a big part of that. There's a little bit about heating and cooling, but a lot of that provisions come in the mechanical code. And the equipment, you can't buy equipment in this country that doesn't pass code. You can't sell it, I guess, legally that doesn't pass code from an efficiency standpoint. Ductwork, however, very important, and so there's some important provisions about ductwork. And then lighting, as we mentioned, for the first time ever, shows up in a residential code. Things like refrigerators and dishwashers are not covered by this code. That's not regulated in this sense. Does anybody have questions about this? Okay, so it's kind of an overview. There's also some things that Georgia has done to, in essence, augment the code or modify the code. And sometimes we've done some things that end up in the code itself. Some of these are carryovers from the previous version of the code. But the supplements and amendments, which we gave you, you have a complete copy of these in the back of your binder.
Behind your blue tab.
And we'll be referring to them in a little bit. But these supplements and amendments you can also get for free from the DCA website. Okay, just so you know if you want to get these. A couple examples are, we actually require that wall between the attic and the conditioned space has to have better insulation, right? Does anybody know how much insulation you have to put on an attic knee wall? Everyone go. That is the correct answer. R18 is the right answer. We got a shy crowd. Everyone's afraid to say the wrong answer.
Come on, man. I was giving it over here.
I know you were. R18 is the code requirement for attic knee walls. Why would we want that wall to be insulated better than, say, the exterior wall over here? Why would we care about that?
Because that attic space is very...
Thank you. Thank you. You completely... Because attics are what?
They're blast furnaces.
Very hot. They're very hot, right? So, and I've done some training in Texas before. They actually call that the hot wall. I thought that was a great name for it. They don't call it a knee wall. They call it a hot wall. So an attic knee wall needs to have more insulation in it. That's an example of where we modified our code. There is no trade-off for that. It has to add up to be R18. You can do it. It has to be. It has to add up to 18. It has to have an attic side air barrier. So you can't just say frame it with a 2x4 and stick an R19 bat hanging out in space. That does not pass code. You can frame it with a 2x6 and put an R19 bat in it. R19 as a bat is about a 6-inch, 6.5-inch bat. What happens to fiberglass? What happens to fiberglass when you compress it into 5.5 inches in this case? What happens to the R value?
R18.
It goes down a little bit. It goes down to R18, in fact. And so that's why we said 18 was an okay number. And then you would also, if you frame it like that and put fiberglass, you would need to put a rigid air barrier, such as Norboard OSB would be an excellent attic side air barrier. See how many times I can put a little tick mark every time I say that. I'll get a free plug for you. So the thank you. So the attic side air barrier is the OSB, and the insulation is the 2x6 cavity with R19 slightly compressed. You could also do it with a 2x4 wall with an R13 bat and put an R5 foam board on the attic side. Some foam boards are acceptable to be left exposed. There's some jurisdictions will accept the blue boards and pink boards, but they'll all accept this product called Thermax. So you need at least R5. Or you could frame it with a 2x4 and put a high density fiberglass bat in there, like an R15. And then put a foam board on the R3 on the backside. So, however you get it, if it adds up to 18 and has an attic side air barrier, that's how you do knee walls. I just kind of went through that as an example. We've also beefed up our windows a little bit, made it more consistent, really. We have great pictures to help demonstrate air sealing. We've got a thing that says you can do trade-offs in Georgia. We just don't want you to trade something away to zero. That just doesn't make sense. Because having some insulation is always a good thing. Like Roxanne said, the code requires more efficient lighting. We give you credit if you have these things called vacancy sensors or occupancy sensors. And then ductwork. We got tough on ducts this year, and ducts may not be sealed with silver tape. That's basically a prescriptive thing. You cannot use silver tape to seal ducts. Tape fails, frankly. It really does. It might work in a lab, but it doesn't work in the real world. Tape fails. So you can use tape to assemble stuff, but you got to cover it with mastic. Okay? Mastic is pretty cheap. This carries over. If you've got a central ducted system and an air conditioner, the cost to upgrade that air conditioner to a heat pump would be very minimal. The savings would pay for itself in about a month of operation or maybe 2 months of operation. So no electric furnaces if you've got a central ducted system. We also got rid of power attic ventilators. Almost. We almost got rid of power attic vent fans. And
we'll show you why.
Yeah, we'll talk about why those aren't a good thing. But basically the short answer is they use electricity to supposedly save you electricity, and they really don't. So we're not saying don't vent an attic. We're saying don't vent an attic with a fan. Okay? Not a whole house fan. A power attic vent fan. Does everybody understand the difference, what I'm talking about? Okay. And probably the biggest thing on here, Roxanne, the test.
Is when we're doing that performance testing of that building envelope as well as your ducts. It's actually something that we did in Georgia. It's required to have the envelope test, so that blower door test, on all new single-family homes. That is required. There are some optional methods that you can do for multifamily, but for single-family new construction homes, you must have a blower door test. And we also say who can do these tests. We'll get into who can actually perform these tests later in the day. But
basically, one of the questions we get a lot is, if the HVAC installer roughs in their own duct system, does a third party have to come in and test the ducts, or can the HVAC installer test their own ductwork? And actually, the answer is they can test their own ductwork as long as they are qualified to do it. And the same goes for you if you're a builder. If you build your house and you are qualified and know how to do it, you're allowed to test the envelope on your own house. So I want to be real clear about that. That is, the code was intended to allow you to do that, but you have to know how to do it. I suspect probably a lot of home builders, you're in the business of building homes, not testing houses. I suspect you'll probably more likely sub it out. But HVAC contractors, I think, are more likely to potentially want to do the test because they've got they potentially have the equipment anyway. So I don't know. It's up to you. It's up to however it goes. But I just want to be real clear about that. Okay? So you have to be qualified, and we'll tell you about how you can get qualified. Any other questions? Well, I'm sorry about that. Yeah.
We'll go back to number 7, no electric furnaces. We can still have that as backup with heat.
Absolutely, you can have it as a backup. An electric furnace, though, is one that literally is just a coil with a blower and ductwork and a resistance
you're heating
thing.
your house with a toaster.
Yeah, and this is if you think about it, remember how we talked about how inefficient that was? That's why this is in here. Literally, if you do the number crunching on it, if you're putting in an air conditioner, the cost to, instead of having an air conditioner, have a heat pump, the incremental cost, you will save that in one heating season easy. Yeah, well, you say that, but yeah, I can't believe anybody would do that. But and yet someone fought us hard on this, believe it or not. So, all right, keep going there, my friend.
All right, so in the actual layout of the 2009 IECCs, the first part is kind of some administration stuff. The second part is really good for definitions. This is really good for when you kind of get into a nitty-gritty situation, what does conditioned space mean? We're actually going to go over that today since that seems to be something that keeps reoccurring. Between the 2009 IECC and the Georgia supplements and amendments, they've really tried to clearly define things. Chapter 3, again, going over those climate zones. We have 3 in Georgia. Do I have any climate zone 4s here?
We'll find out.
Okay.
We'll find out.
Then the Chapter 4 residential code, that's actually what we put in your binder, that excerpt. That's what is actually in your binder. It kind of goes over some general things. Again, talking about that building thermal envelope, the requirements there, window requirements. Again, touching upon that lighting. I swear it's like one paragraph. And then finally, the performance alternative. We'll talk about that simulation software briefly. Any people in here do commercial code?
Or anybody work in the commercial world as well?
We got couple, all right. You can use the Chapter 5 in here for your commercial code, or you can reference ASHRAE 90.1. We have found at Southface that ASHRAE 90.1 is probably more often used and is probably a little simpler to use.
And we'll show you at the end where you can get the ASHRAE 90.1 almost free for literally $19, which is dirt cheap for something from ASHRAE. So I'm looking at y'all over here as designers. But if you run into that, we also are teaching. That's the second time today. We are teaching workshops on the commercial code. We actually taught one yesterday, and so if you're interested and that's something you're up for, we can invite you to come to one of those workshops as well. Okay, the big thing though that I think is really telling about this is this whole book right here. This whole book, which again you can get for free, in essence boils down to about 6 pages, and it's 6 pages of Chapter 4. It's these pages right here. And guess what? We gave you those 6 pages. They're in the back of your binder. So really the whole code is boiled down to 6 pages plus the Georgia amendments, and you've got it all. So I don't even think you really have to have this book, but if you want it, it's there. Okay? From a picture perspective, if you're like me and you don't like to look at words, but pictures do it for you, kind of a graphical representation of what we're going to cover today is, first we're going to talk about the scope of the code, and then we're going to make sure we understand that in terms of the building thermal envelope, that's the insulation and the windows and things like that, there's 3 ways to comply with the code. The prescriptive code, which is just tell me what to do. It's one answer. If you follow the rules, you're done with that part of the code. If you want to vary from that, that's okay. You're going to have to do a trade-off. And there's sort of a simple trade-off tool. And then there's also a much more sophisticated, complicated simulation pathway. Most builders go this route. Some people will do this for something simple, like say I want to put spray foam on a roof line. And then this one typically doesn't have to happen, but it might happen if you're doing a beyond code program.
Does anybody here use or is a HERS rater?
There's a thing
a
called
home energy rating system. It's a course that we teach at Southface. It's a very in-depth annual simulation software, and we affectionately called the last one the Architects Gone Wild one.
So that's the Architects Gone Wild pathway over here. I'm looking at the architects over here because this is the Architects Gone Wild pathway.
Yeah, we love you, but at the same time, sometimes we have to model your house as using the last one.
So you always have that as a last option, but almost all the time, as long as you just follow this pathway, you're fine, or a simple trade-off can be done with this tool. The tool to do this is also free, and it's a tool called ResCheck. Has anybody heard of ResCheck before? We'll try to demo that and show you. It's actually very easy to use, and it's free, so it's a nice little tool. And then at the end, there are some very, very important mandatory requirements. Some things that you cannot trade off. You have to do them. There is no trade-off for air sealing. There is no trade-off for duct sealing. You must do them, and now you actually have to prove that they were done right by testing them. Okay? So that's, in essence, the way the code goes. We're going to go sort of kind of knock some of these out and then do some building science stuff.
So this applies to new construction, single family, either one or two family, and multifamily 3 stories or less. When you get above 4 stories or higher, you're getting really into the commercial code, but 3 stories and less apply to the residential energy codes. Exempt buildings. So that first one, it says there, what's an example of a no conditioning building that might be on your property? You might put your car there, your tools there. What is that called? Your detached garage. Your detached garage does not need to meet energy code, does not have to have extremely well thought out windows because you're not heating and cooling that space and it's detached from your house. Also barns, sheds, that kind of falls into that category. Historical, it has to be registered on historical, your local historical accreditation.
Yeah, it's all in Chapter 1, which we gave you that page, but basically eligible for listing or listed or something like that in state, local, or national register of historic places or something.
There you go.
Something like that.
Low peak energy for space conditioning. I still have not seen one of these yet, but it's one of those homes that is so efficient and so tight that the way you basically heat it is with a light bulb.
Yeah.
Okay, maybe not really, but usually, we're really up in the top level here. Also, any additions, repairs, or alterations have to meet code. So if you put in a new window, does it have to meet code? Yes.
Yeah.
You build an addition on your house. Does it have to meet code? Yes. So that's kind of the residential overview here.
So a lot of builders have now become renovators.
Mm-hmm.
Anybody in this room fall into that category, perhaps? I'm now a remodeler, right? So good for you for changing your title. That was a smart move. And so how does the energy code affect renovations? I want to make sure we cover this in a little more depth. But what Roxanne said was basically dead on correct. The simple rule to always remember is that all new work needs to meet code. Okay? And in general, the general rule is if you touch it, you need to bring it up to code. If you don't touch it, what do you think? Leave it alone. It's okay. So in other words, if you mess with something, bring it up to code. If you don't, in general, you don't have to do anything. I think that's the simple way. That rule is generally always correct. There's a couple little exceptions up here. I want to make sure we cover these. The first exception, it says, if you have an existing home and you simply go to it and add storm windows, the code is not going to kick in. The storm windows will not make that home all of a sudden be in compliance with the code,
Nope.
but they will make whatever was there work better. Would you agree with that? So,
You buy that?
I'm not necessarily trying to advocate storm windows, but they do make the existing single pane window usually better. So the code doesn't kick in. Code says that's fine. If someone throws a baseball through your window and it breaks, and you repair that window, that's okay. All right? So in other words, repairing a window, the code does not kick in.
Putting in that pane of glass in.
Right. But if you say, you know, someone broke that window, and we've been meaning to replace all the windows on the front anyway, this is a good time to replace them all. Do the replacement windows have to meet code? The answer is yes, they do. So everybody get that? So replacement windows meet code. Repairing windows, that's okay. Repairing a broken window. All right, Roxanne, number 3.
All right, so this kind of falls into 3 categories. All right, so let's use these walls over here. So we got these 3 walls over here in between the windows. Everybody see them? Or maybe I'll go over there. All right, so in this first wall, I take the drywall out. I see there's no insulation, right? I've removed the drywall. Or go to the stud cavity. There's no insulation. What do I need to do in this wall cavity? I need to insulate it. Does anybody know what I'm insulating it to?
What's the R value for walls?
R13. I heard it. Great. So, you know, I'm remodeling. I put R13 back in there, put the drywall back up. Over here, I know this wall is the same as this wall. I know that there's no insulation here, but I don't touch it. Do I have to do anything? Nope, I don't have to do anything because I didn't open it up. I didn't expose it. Also, back here, when we put in that insulation, should we be air sealing around that? Oh, yeah.
Yeah.
All right, so now I go to my last wall. I come to this drywall. I take it off. I see existing insulation, but let's call it R11. What do I do there?
Well, you probably ought to.
Very interesting. If there's R11 in here, by the energy code, because there's existing insulation, I do not have to replace it. However,
it's probably disgusting, and
it is probably disgusting. It's probably not operating well. You might not want to be associated with a poor performing wall, so you might upsell the service to the homeowner saying, I'll be glad to replace this for you for R13. I'll do you good work there, air seal it and everything, and then put the drywall back up. But by the energy code standards, you don't technically have to replace it. Should you replace it probably as an up service to your client? I'd say so. I don't think I want my name associated to a wall that's poorly performing.
Yeah.
So,
as long as, but if you tear into a cavity and it is insulated, as long as the insulation fills the cavity, then you're not required, in essence, to rip it out and start all over again. Okay? Does anybody have questions about that? Because that's probably the key things from a renovation standpoint that we want to make sure we cover.
What is insulation?
Pardon?
If it has Dow board on it, is there going to be an insulation?
Dow board, like blue board or something?
Kind of.
That's unless it fills the cavity, which would probably be unlikely. Yeah, it's the cavity insulation they're talking about. So what they're really getting at is if you tear into a cavity and it's empty, you have to insulate it. Or you tear into a cavity and there's some insulation in it, as long as it fills the cavity, then you can leave it. Okay, that's a good question. Any other questions on that front? Everybody good? Yeah.
On a HVAC system, if I go in and replace the system and don't touch the ductwork, leave it as is if the customer...
That's a really good question. So the question has to do with replacement HVAC units. And I'm going to tell you the answer to that is coming up. It's on a slide in the end, but I'll give you the quick version now, okay? So the quick version is you do not have to test the existing ductwork. If you don't mess with the existing ductwork, you do not have to seal it. But no matter what, when you replace the equipment, you do have to seal the plenum. So that's the short answer, is the plenum. And I promise we'll cover that in more detail, but that's a great question. And it does kind of have to do with upgrades to an existing home. Do you have any other questions to remodeling? So I think hopefully it's pretty straightforward. Oh, another question we get a lot of times is, what if I build an addition onto a house or I renovate part of a house? Do I have to do a blower door test on the whole house? And the answer is no. Okay, so unless you do what we call a gut renovation, or I think the code says, in other words, unless you touch all aspects of the building envelope, And you know, that if there's confusion on that, I always say go to your code official for that one. But, you know, if there's a gut rehab, okay, you're stripping the whole house down to the studs and everything. You've pulled out the ceiling drywall. Okay, when you build that back, you need to test it. But if you're just messing with part of the house, or if you're just building an addition, you do not have to blower door test the whole thing. Does everybody get that? Those are probably the two big questions we get about that. Good question. Any other ones? All right. We're going to move on and say conditioned space. Conditioned space, it's pretty much what you would expect in terms of if you put even the smallest amount of supply air into a space, it's considered conditioned space. If you put the smallest amount of heat or cool into a space, it's more or less kicked up to conditioned space because the thresholds are so low. The one term that's kind of very explicitly spelled out is this term called indirectly conditioned space. All right. This would be probably the best example I could give you would be someone has chosen, instead of insulating on the flat ceiling, they've chosen to spray foam along the roof line. Have y'all seen this before? You know what I'm talking about? And there's a lot of products that can do that, open or closed cell, or just for whatever reason, they've moved the insulation along this roof line. You do not have to directly supply air to that space. You can if you want to, but that space that used to be an attic is now considered indirectly conditioned by the floor below it. Does that make sense? So that's just to really help clarify it for everybody involved, that is inside the building envelope. That does count as conditioned space. It's just not directly conditioned. Another example might be you do a walkout basement, maybe it's unfinished, and you choose, instead of insulating, you know, sort of the floor that's over the basement, you choose to insulate the walls of the basement. You might not be putting any supply air in the basement, but that basement is essentially connected to the house. So that, in that case, that's still considered an indirectly conditioned space. It's inside your building envelope. Does that work? Okay. So that's, I think, just to help clarify that for everybody involved. All right. Okay, chapter 2, Roxanne, not a whole lot to say here.
Basement walls, the only thing here is basement walls, 50% of it has to be below grade.
Yeah.
Everybody can agree to that?
It's a good chapter. I mean, it's
chapter.
About 5 or 6 pages of definitions. That might be one argument why you want to download that, because it's got that good content in it. But pretty much, you know, most of it's fairly straightforward. So that's what chapter 2 is. Chapter 3 looks like this. Find your state.
Now can I ask?
Yes, you absolutely can.
All right. How many climate zone 4s do we have?
Well, if you're not sure, by the way, if you can't read, this will help you. So is anybody here from Floyd County?
We got 2. All right, climate zone 3. I'm going to guess most of you are going to be putting your hands up here. All right, climate zone 2.
Anybody from zone 2?
Oh,
really?
Man, you had a drive.
Really? Where'd you come in from? Okay, you
You came from Orlando.
That's like...
Woo!
You've come before, haven't you? Yeah, I thought so. You came to the DET training. That's it. I'm sorry, I'm slow on the draw. I'm slow on the draw. And you too, right, Ken? I'm really slow. I apologize. It's connecting. Okay. So bottom line is... some people right here, we're kind of on the cusp, because I think Paulding County is zone 3, right? And Floyd County is zone 4, I believe. Is that correct? Tell me if I'm wrong. So if you look on your map there on that handout, that's probably the easiest way to see it. And it's kind of fun to watch some of y'all have to hold it really far away, because it's good to think that you're going to be wearing glasses soon. I like to think that. That's good. So bottom line here is you figure out your climate zone, and then you figure out what prescriptive code package you use, and that's pretty much it.